All right, Passerians, welcome to this video on quadratic word problems, which is finally the time that we get to do one of the coolest things. We get to deal with gravity. You guys all know that song by John Mayer, Gravity is Working Against Me. Gravity wants to bring me down. Well, gravity wants to bring everything down at a rate of 32 feet per second. And we're going to use half of that quantity. So we're going to use 16 for gravity all the time. And gravity is going to be pulling things down or up. Well, we know, according to John Mayer, gravity wants to bring me down. So gravity is always going to be a negative value. So for this course, we're going to use negative 16 for gravity, feet per second. So everything that you're dealing with is feet. So notice this guy, he's jumping off of a cliff, not recommended to you, by the way, because those rocks underneath could come out and he could hit one of those rocks. So you should not try this at home, okay? I want that to be clear. But this guy must be professional, or maybe he's a stunt double or something. He's jumping off of this cliff. So again, disclaimer, I do not condone you cliff jumping from a height of 48 feet. So the question is, when does he hit the water? He jumps up at 8 feet per second. So it's kind of like listed right here that he jumps up at 8 feet per second. Kind of cool. So right here is 8 feet per second. And this is at time 0. So he starts by jumping 8 feet per second. And the question is, when does he actually hit the water, which is at a height of 0? When does he hit the water, which is at a height of 0? And we know that his initial height is 48 feet. If you took a tape measure and measured, he would be 48 up there. So a diver is jumping from a ledge. The vertical component of his motion can be modeled by the vertical motion model, which is a very clear thing that will always tell us in real life. This is not a joke. If this was a real situation, we would find the time he hits the water. If you were at a quarry and you jump from 48 feet exactly, up at 8 feet per second exactly, you would hit the water at exactly this time. This is not a made-up thing. So how long will it take until the diver enters the water? Use a vertical motion model. So I want to explain to you this equation right here. It's probably looking a little confusing because there are, 4 variables there. S is green for a reason. S is green because we're going to call that the starting point, or you can write start. So please fill that in. This is the starting point that he's at. So starting point. So in this example, what do you think S is going to equal? Where does he start? 48 feet. So starting point is 48 in this example, for this example. V stands for velocity. That means speed, but with a direction. So in other words, speed is only positive. You can't have a negative speed. But velocity is speed that could be positive, could be negative. Now this velocity is his initial velocity. When he does actually jump, so he bends his knees and he jumps up from this cliff, and he jumps up at what rate? What is his initial velocity? And does he jump up or down? He jumps up, right? At what velocity? Velocity. What was the speed again? And this is kind of like speed-ish, I'm going to say. And that was, for this example, the velocity was equal to 8. Okay? Now, the last one is red. So red means stop. Red is where he stops. So at what time, we want to find this diver, and we want to see when he hits the water. I want to ask you how high up he is when he hits the water. How high up is the diver when he hits the water? 0, exactly. So whenever I say hits the ground, this is the final height. I'm going to put final height here. Final height. Make sure you write that down. And in this case, the final height is 0. These problems are pretty simple because now all you have to do is fill into the diagram. So we're going to fill into the diagram these values just right here and see what we can come up with, okay? So start with the final height. We know the final height in this case is 0, so I'm going to put that here. Final height is 0. We know that the velocity that he's going at, so we don't know this. We don't know this, but we do know the velocity that he's going at is 8. So that's from over here, 8t. And we do know that the starting point that he was at was 48. So after all of that work is done, there's a lot of work obviously involved in thinking about what's what. But now that that's all done, we are good to go. We are ready to Oops, sorry, that should have been in blue. We are ready to solve this equation. So velocity is here, initial velocity, and then speed or starting point is here, 48. So does everybody understand what we've done? We've taken gravity, which is going to pull things at negative 16t squared for this class. That's actually half of gravity, by the way. And it's negative because it's pulling things down. He jumps up, so that's a positive 8 because he's jumping upwards. He's trying to get up into the sky, but he doesn't make it. He falls down. And he falls from a height of 48, and he finally winds up at a height of 0, right? Sea level. So now the question is just, can you solve this? That's all you got to do now. All you got to do is solve this. So I'm going to take this equation, and I'm just going to take it out of the whole like confusing context of whatever that problem was, and I'm just going to bring it all down here. So now we're just going to work on this equation only, and forget about all of that other stuff for just a few minutes. So take a moment of peace, and just look at this equation and see if you can solve it. Well, I don't really prefer the 0 on the left side, so I'm going to just erase it, and I'm going to put it on the right side just because that's how we've been doing it, and I would prefer it to be over there. Look at the problem and ask yourself the first question that you will always ask: is there a GCF, a greatest common factor? Is there a GCF? Yes. What would we take out? Yes. Perfect. So 8 is the GCF. We also always want to take this negative out. So word to the wise, for these problems, you're always taking out a negative because gravity is always negative. So if we take out the negative 8, we know that this would be 2t squared minus 1t minus 6. Take a second. See if you agree with it. See if you disagree with it. The reason that I know that that's the answer is because I personally believe, if I were to distribute this like that, I would get this, this, and this. Do you understand that? You cool with that? Now, I don't like the way that the problem looks right now. Not that I should be discriminating against the math problem because of the way it looks. That wouldn't be right. That'd be wrong. That'd be discrimination. But I don't really like how this problem looks right now because it has that negative 8 in the parentheses, and it makes it look kind of weird. Or ugly, you could say. So I'm going to get rid of the negative 8 by dividing by it, okay? Good thing this is a math problem and not another person, because we can't do that, in these days. So now we have 2t squared minus 1t minus 6 equals 0, okay? So we're going to look at that, and we're going to break that one down. Nicer looking problem now. And we're going to find the exact time when this diver hits the water. So we're going to use this method because we can't take anything else out. Thoughts on what we should do for starters? Think about this problem for a second. So what do we need? 2t and t. So 2t and t. And then what do we need here? We need 6. So what can multiply to 6? 6 and 1 or 3 and 2. Okay. So we're either going to do 2 and 3 or 3 and 2. So why don't we try for a second, let's try 2 and 3 and see what happens. Well, with that, our outsides become 6t, our insides become 2t. Does that work? No, that's not going to get us 1t anyway, no matter what we do. So that's not going to work out. So I'm going to swap around the 3 and the 2. I'm just going to swap them. And I'm going to see that the outside comes out to 4t, and the inside comes out to 3t. I know that if I had a negative 4 and a positive 3, I would have the answer. Now, we're not quite done. We just need to solve out those two factors, right? I know, we got to solve out those two factors. So we're going to set those equal to 0 and see where it goes. So really right now what we need to do is set each of these factors to 0. So we got to take this factor, 2t plus 3, and set that to 0. And we got to take this factor, t minus 2, and set that to 0. We know this is going to come out with a time of 2 seconds. And this is actually going to come out to a negative time. It's going to come out to a fraction. 2t is equal to negative 3. So t is equal to negative 3 over 2. Well, could we have hit the ground a second and a half before we jumped? No. So we're going to throw out this time because it's a negative time. And we know it didn't happen in the past. We know that he hits the water in the future. So it takes the diver, because remember, this is a problem about a diver. It takes the diver 2 seconds to hit the water, to hit the water. And that's really it. That's the problem. So hopefully that was at a good speed. We'll talk about another problem in just a moment, and just try to make sure you have some pretty good notes, and we'll take it from there. Even a bit rude for me to put this meme on, but I found it to be pretty funny. There's a lot of math in video game design, guys. A lot of calculus, a lot of advanced math. So watch out for that. All right, so we're going to press on to another problem here, and kind of talk about this problem. We're standing at the top of a really tall building, let's put it that way, 1680, right? And we throw a small object upwards. We measure the distance from the object from the ground. This is the equation. So they kind of like put everything in there. So you kind of might see right here, the green, this is our S, this is our starting point, our start. And you can kind of see that because that's where we were on the building. We threw the object upwards, which means that the velocity was positive. Velocity, right? Velocity is positive. And you can kind of see that that's kind of cool because here's the velocity right there. Now this question is talking a little bit more about the details of things, kind of like, really like, what is h of 3? So this is a little bit of a review, if we think about it. H of 3 is when we plug 3 in for the time. So we need to take this problem, we need to plug in, not time actually, we need to plug in 3. So let's look at what that's going to look like. Well, I'm going to erase these areas where I had time, and I'm plugging 3 there. So 3 is going to go here, 3 is going to go here. So 3 and 3, right? Those are not nice arrows. Now I want to just work on that, which is going to be, let's see, negative 48, positive 6, 750, 768, I hope, plus 1680. I did that in my head, so hopefully I got the right number. And now, oh, there's a mistake. There's a big mistake here, actually. It's because this is squared. This 3 is squared, right? So this should have been 16 times 9, right? Because this is 9, and this is negative 16 times 9. Well, I know that 16 times 9 is going to come out to, that's 54, and then that's 9 and 5 is 144. So this is going to come out to negative 144. If it's okay, I'm going to erase that. You can always go back and look at what I did. And now we'll have a better idea of what's going on here. So what we have now is, well, the 768 minus the 144, that's 624. 624 plus the 1680, which is where it was, and that's going to be, I would say 2304 feet is probably where that object lands. Hopefully there's not a mistake. If there is, I will try to edit it out. So they then ask, how much does the object travel during the 2 seconds between 5 and 7? Can you just look back at part A and find h of 5 and find h of 3 and h of 7 rather, h of 5 and h of 7 and subtract them? If you just do that, you'll be okay. That's how far it went, because that's the place that it was after 5 seconds and the place that it was after 7 seconds. And if you subtract those, you should find how much space there was between those two things. So it's almost like you're taking the tape measure and measuring how far it was at 5 seconds. You're taking the tape measure and measuring how far it was at 7 seconds, and then you subtract them. So this is going to be a now you try, because it's the same thing that we just did in part A. So now you try part B. So you can pause the video and give that problem a shot right now. Now, in the next problem, and a lot of these might end up being now you tries, honestly, it says how long does it take for the object to reach a height of 2640? Well, if we think about that, right, and we know that the vertical motion model is this right here, we know that this is the vertical motion model, right? And we want to look at that for a second. So let's get rid of some of this stuff that's in the way. We want to know when the thing reaches a height of 2640. So what we want to do is we want to replace these values here that we had with the things that we know. So do we know anything about this? Well, we know that we have a few different things. We've got, actually we already have these things filled in, so we don't need to focus on that. All we need to know is the final height, right? So all we need to do is really realize that the final height, right, if it's 2640, this means that the h, the final height, is 2640. So we need to take this h, which is h of t, we need to have 2640 equals, and then that whole equation, negative 16t squared plus 256t plus 1680. Yeah, it's going to be a little bit of work. Use a calculator. It should factor okay. So set it to 0, factor it, set the factors to 0, and go from there. Look back at the previous problem if you need to, and then also part D is going to be a now you try. So this is also a now you try, and that's going to be where this video ends. So you might have a handout that goes a little bit further than that, but I don't want you to really worry about that. We're going to try, now you try, B, C, and D on this, and that's really all you got to get done. This is going to be part B of the video. So when we do get there, just so you're aware, 6.6b notes are going to start right here. So I'm over time. I want to stop there. You got a lot of now you tries, the B, C, and D from that problem, and I will see you in the next video. Thanks for watching. Peace.